My name is Sherilyn Nabila Ita Anak Mamat as a team leader.
My name is Nur Fazana binti Tajul Asikin.
My name is Muhammad Daniel.
And our supervisor is Madam Azini Amiza binti Hashim.
I will present 4 introduction first. First, the fuel briquettes are carbon-containing solid fuels with a high calorific value and extended ignition duration. Second, fuel briquettes are a sustainable and consistent fuel option of household. It can be produced from renewable material. Then, examples of renewable materials are food waste, charcoal dust, and coconut waste. After that, problem statement. Malaysians wasted around 39 tons of solid trash every day, and majority 13.6% of household. Charcoal dust is often thrown away, causing resource waste and polluting the environment. Containing a high calorific content, coconut waste including husks and shells is also wasted. These materials to produce fuel briquettes waste disposal problem could be reduced while encouraging renewable energy sources. Then, this is the objective of our project. Firstly, to produce fuel briquettes from food waste, charcoal dust, and coconut waste. Second, to evaluate the physical and chemical properties to fuel briquettes from food waste, charcoal dust, and coconut waste.
I will explain the scope of study. First type of sample we produce in this study. Fuel briquettes from food waste and charcoal dust. Second, fuel briquette from food waste and fine coconut waste. And third, fuel briquette from food waste and rough coconut. Fuel briquette is in cylindrical shape, and the resulting briquette we are dried in oven at 105 degrees Celsius for 3 hours or completely dry. Produced briquette were examined for physical and chemical characteristics such as shattering index, ignition time, density, moisture content, scanning, electron microscopic test, and calorific value. Then, literature review. Biomass briquettes are a biofuel option for coal and charcoal. They are mostly used in developing countries when the supply of cooking fuel is low. The ultimate product is a biomass briquette with enhanced volumetric energy density, simplifying storage and transit. The production of fuel briquette from food waste, charcoal dust, and coconut waste is aligned with the Sustainable Development Goals (SDG 7) to ensure access to affordable, reliable, sustainable, and modern energy for all. Food waste may be transformed into a variety of renewable energy sources using different techniques, greatly advancing sustainability initiatives. Charcoal is brittle and produces more dust during handling and transportation. This dust can be harmful to health, which emphasizes the significance of developing better production methods and looking into alternative feedstocks. The production of coconuts in Malaysia had increased to a total of 536,606 million coconuts, which further exacerbates the problem of the building of trash from coconut. Methodology Stage 1 Collection and preparation of raw material. Stage 2 Production of fuel briquette from food waste, charcoal dust, and coconut waste. Stage 3 Physical and chemical properties test of fuel briquette. Stage 1 Collection and preparation of raw material. Food waste and charcoal dust and coconut waste we collect from variety of locations such as house, grocery, stores, and restaurant. All raw material are grounded into smaller size to enable the uniform mixing during the fuel briquette production. The raw material were dried in the oven at the 105 degrees Celsius for 3 hours or until the raw material completely dry.
I will continue with stage 2, that is production of briquette from food waste, charcoal dust, and coconut waste. We had 3 types of sample, which is food waste and charcoal dust, food waste and fine coconut waste, and food waste and rough coconut waste. Each type of sample had 5 samples. The mixture of sample ratio is based on this table. To shape the briquettes, we use PVC pipe by using manual pressing method with size of PVC pipe as 25 mm internal diameter and 25 mm height. The fuel briquette produced are stored in desiccator for preserving the briquette quality. After that, for stage 3, we will present tests that conducted on the briquettes. First, physical properties. density, moisture content, shattering index, and ignition times. For chemical properties, scanning electron microscopy test, SEM, and calorific value. In the density test, we can see the pattern of graph the food waste and charcoal dust samples show a decreasing density trend as the charcoal dust proportion increases. This is because charcoal dust becomes volatile component and increase carbon-carbon concentration. It will result compact and dense structure, while food waste and fine coconut waste samples show a lower density. This is because coconut waste density depending on particle size, so fine coconut waste tend to produce less dense briquette compared to rough coconut waste. After that, moisture content for briquette is food waste and coconut waste. Possesses highest moisture content, peaking at ratio of 50 of fine coconut waste and 50 of food waste, while food waste and charcoal dust have lowest average moisture content. This is because charcoal significantly reduces moisture holding capacity, meanwhile coconut has natural tendency retain moisture.
Then, for the shattering index, the charcoal dust and food waste has the lowest shattering index because of causing several cracking, while fine coconut waste and food waste contains the highest shattering index.
Burning time. This graph shows how long each briquette burns. Food waste and fine coconut waste has the longest burning time, peaking around 38 minutes, which means it sustains fire longer. Food waste and charcoal dust has a moderate burning time which is 20 to 25 minutes, while food waste and raw coconut waste burn the shortest, which is 5 to 7 minutes. Ignition time. Food waste and charcoal dust and food waste and raw coconut waste here longer ignition time, around 1 to 1.4 minutes. Food waste and fine coconut waste ignites faster, with an average of 0.56 minutes. This means food waste briquette are easier to ignite, while dust with coconut waste or coconut dust require more time to start burning.
This is the result for SEM test. This test is proof the shattering index of briquettes. For example, ratio 50 of charcoal dust and 50 of food waste, medium density value due to moderately porous structure with visible voids and irregular particle arrangements. At 5000 times magnification, weak interparticle bonding and microcracks indicate limited compactness. This result, the sample shows the lowest shattering index, while for the sample ratio 75 of coconut waste, fine, and 25 of food waste, porous, compact structure with interparticle bonding and surface roughness. Despite moderate densities, 99.75% shattering index indicate high mechanical integrity. Briquettes with good binder distribution and structural cohesion have high shattering resistance. Last but not least, for sample ratio of 50 rough coconut waste and 50 of food waste had high picking efficiency result in a density of 8.742 gram per centimeter cube, while lower porosity and increased particle contact increased bulk density to composite briquettes materials. This sample had high shattering index of 99.89% indicates strong resistance to mechanical breakdown, improved interparticle bonding and reduced internal flaws, increased mechanical durability.
For the test of calorific value, two samples were tested, which is 0% of rough coconut waste and 100% of food waste, and the calorific value is 15.1690 megajoule per kilogram. For sample 15% of fine coconut waste and 15% of food waste had 15.5545 calorific value. The briquette with 15% coconut waste had a slightly higher calorific value, meaning it produced more heat energy compared to 100% of food waste. Both samples meet the minimum calorific value standard, proving their potential as alternative fuel sources.
For the conclusion, production of food briquettes using food waste and fine coconut waste offers great potential in terms of longer burning time, less shattering index, low moisture content, and acceptable calorific value for cooking. Application. The utilization of waste in the production of pre-briquette could promote environment-friendly alternatives to reduce the improper waste disposal, and the best sample for fair briquette is sample with ratio 50% of food waste and 50% of fine coconut waste because of 99.89% of shattering index and had longest burning time, which is average in 35 minutes.
Recommendation. Pressing of fuel briquette in mold should be done using machine to ensure uniform height for all samples. Dry the raw material properly before mixing the reduced moisture content. High moisture reduces the briquette quality and energy output. Store the briquette in a dry place to maintain quality and prevent mold growth. Project impact. Significantly reduce the volume of food waste, charcoal dust and coconut waste that would otherwise be burned or dumped on the landfill. Converts agriculture waste into valuable energy product, enhancing resource efficiency. Helps reduce reliance on wood fuel, contributing to forest preservation.